Hey everyone, hope you're having a good day. It's Mr. Smith. This is part 3 of my review of one-step equations. As you can see, this time we're going to deal with some fractions, my favorite. So without ado, let's get started. I've got one here that says y subtract 6 is equal to 7/8. Now, really what I would like you to think of is, let's not worry about the 7/8 because that is not attached to the variable. In other words, the 7/8 is not on the same side as the variable. It's really the 6. So the rules of algebra don't change. You have to get the y by itself. You have to get the variable by itself. That's called isolating the variable, okay? It's kind of like what we're doing right now with our pandemic. We're isolating. So we have subtract 6. What's the opposite of subtraction? Yes, it is addition, okay? And so whatever you do to one side, you're going to do to another side, okay? So what happens here? Well, you get a nice little zero pair. In other words, the 6's cancel, which is what's supposed to happen. And then on the right, you have 7/8 plus 6, okay? Now, there's a couple of ways of thinking about this. You've been taught that when you're adding fractions, you need a common denominator. In other words, 6 is the same as 6/1, right? And so we would have to multiply this by 6, and then we could get it, we'd have to multiply it by 8, to get a common denominator and add it. But isn't there really more of a common sense way of looking at this? Like if I thought of this as, whatever, apple pies. I have 6 whole apple pies, right? And I have 7/8 of the 7th pie. Don't I just really have 6 and 7/8 all together? Do we really need to go through the whole, rigmarole, to use a good word, of finding a common denominator? Can't we just simply accept that we have 1, 2, 3, 4, 5, 6, and 7/8 of this one? So we have 6 whole pies. And isn't that nice, that Pac-Man there? And we have 7/8. So don't we just have 6 and 7/8? All right. I don't want you to take a lot of time. If you just have a simple whole number to add to a portion here, then really you can just stitch these together. You can just glue them together. It's 6 and 7/8. Okay. All right. That's basically my comment on that one. Let's go to the next question. If it'll toggle for me. Okay, so here we have a adding 3/4 is equal to -1/4. Okay, again, I don't want you to get fixated on the right side because it's not attached to the variable. We're only focused on, in the beginning, what is being done with this variable. What's the relationship of this variable to whatever's coming next? It could be a whole number, a decimal, a fraction, whatever it is. So the relationship is addition. That's what I want you to focus on. So what's the opposite of addition? It's subtraction. And so what are we subtracting? We're subtracting 3/4. And of course, what is our rule? Whatever you do to one side, you must do to the other side. Okay? So that has a nice little effect of becoming a zero pair. In other words, it cancels out to 0. And what are we left with? We're left with -1/4 subtract 3/4. Okay, so what's one thing we notice already? Well, small advantage, I guess. This is not a super complicated problem because guess what we already have? We already have a common denominator. So at least that part is done for us, right? And so now you've got to wrap your head around this whole rules around integers. What happens when we start with negative and we're subtracting, and since this doesn't have a sign, we consider it to be a positive. We're subtracting a positive, okay? We're subtracting a positive. So let's just take a break from the fractions and let's just go with whole numbers. Sometimes if I'm sort of a little bit mixed up or confused, or if I just need to pause and think about what I'm supposed to do, sometimes I'll just ignore the fractions or decimals and I'll just go back to whole numbers. If this was a whole number situation, What would happen if, let's say, we had, oh, I don't know, -4, subtract, and now this fraction is bigger than this fraction, so let's pick a bigger number. Let's say 4 minus 6. All right? Well, we're subtracting a larger positive number. If you remember, subtracting a positive is the same as adding. So in other words, these two can just swap places as adding a negative. And the answer would be -10. Okay? So all I did there was I was just trying to review in my mind what the integer rules are. And because I didn't want to deal with the fractions right away, I wanted to just wrap my head around what is the integer rule that applies. Subtracting a positive is the same as adding a negative. I like when all my questions are written in terms of addition. That's my habit. That's the way I like to relate to this particular rule. Subtracting a positive is the same as adding a negative. Okay, so let's just maybe erase that now. Let's go back to our fractions. Okay. Okay. All right. Oops, gotta go back to the pointer. Okay, so here we have -1/4. It's not the exact same color, but do we really care about it? No. And we have subtracting a positive is the same as adding the negative. Okay. Now, you know when you have a common denominator and you're adding or subtracting, you don't touch the denominator. In other words, you can just write a single common denominator. By the way, this is my favorite step when students are showing their work. I love it when they use a common fraction line and a common denominator that's written once, okay? Because it tells me you know that you're only supposed to add the top or subtract the top, whatever you're doing. In this case, we're adding. So what's going on here? Well, a is equal to -4. We added the top over 4. Simplified, this means a is equal to -1. Now, if we were to check this, this should work out just fine. Switching to purple here. Okay, so let's watch this. Check. What's the definition of a whole number, like in this case 1? Well, 1 is the same as 4 over 4, is it not? Right? If you got 4 out of 4 on a test, don't you have 100% or essentially the whole number 1? You do. So what about -1? Isn't that the same as -4 over 4? So if we're saying a plus 3/4 is equal to -1/4, and we're saying, going back here, that a is supposed to be equal to -1. Okay, so we're substituting in our solution. But we're also remembering that when you have a whole number, you can write it in any form. I could have defined this as like -12 over 12 or -113 over 113. That's still equal to -1. So I chose -4 over 4 because, look, I'm dealing with 4s. So why not redefine? We're going to redefine the 1, the whole, the negative whole, as -4 over 4. Now, what we have now is a common denominator. I can glue these together. We have -4 plus 3 over 4. That's supposed to equal -1/4. -4 plus 3 is -1 over 4 is equal to -1 over 4. And it works. Okay, we checked it and it works. Okay, next question. Okay, I'm just going to pause the video for a moment.